Today is day 5 of Unit 7. We're going to kind of put everything together, trigonometry review. I pulled a bunch of questions from the workbook, but since they're all in different places, I've actually put them on a worksheet for my students. So you can kind of go along with us as we go over, or my suggestion is try to do the problem and then come back to the video to see if you can get them correct. That'll be the best way to determine if you actually know what you're doing with trigonometry or if you need more help with it. Okay, so let's match each equation to the description of the transformation the equation represents. All right, so this is just going back to just transformations of anything. We talked about transformations yesterday. Now, I want you to notice the way that it's written here. You could have this show up on the EOC as well. These are some things that show up just overall in our standards for Math 3. Okay, negative, when there's a negative on the outside, think if that's your A, the A would be negative. Well, what happens? It is a reflection over the x-axis. So this is 1 right here. Or you could say 1 is C. All right. Now, number 2, K. When K is multiplied. Now, they're just using different variables. Yesterday, I said A. Okay. A or K, in this case, when it's multiplied, is what makes it bigger or makes it smaller. So it could be, it is a vertical. And I know I didn't use that terminology yesterday in my video, but here, when it's on the outside, multiplied on the outside, it is a vertical stretch. All right, so E is number 2. All right, now number 3, X plus K. So the K value right here, a lot of times we say X minus K, but here, this is what it does. It shifts left and right. Well, anytime it's a plus K, it's going to shift left. So K is positive or shift to the right when K is negative. So this is going to be B right here. All right, here, when you're adding something on the outside, now when you're adding and that K is positive, it's going to be up right here. But if K was negative, it would shift down. All right, and lastly, right here, we haven't talked much about this, but anytime you multiply inside, this is a horizontal compression or stretch. All right, so this one is number 5. Okay. Now, let's look at these next ones right here. Let's describe, or number 1. So let f of x equal 5 sine x. Describe the graph of each of the following in terms of the graph of f. If you need to, you are welcome to graph it if you would want. So 5 sine of x. And so that's what it looks like. Double check that you're in radians. And we are. Okay, but here, notice what I'm doing. I did plus 4. Okay, so here, if I say 5 sine x and then I say plus 4, let's see what I did. Do you see how the thing just moved up? All right, and it's going to move up 4. Okay, so up 4. And so what that does for us, it actually changes the midline. Okay, changes midline to y equals 4. All right, instead of here being y equals 0, here now it's y equals 4. All right, so let's see what it does here. Now, this is not necessarily a part of our curriculum, but notice that we add 11. That means, not 11, pi. So here we're going left a distance of pi. And you can see what kind of shift this is. This was that phase shift I was talking about. So here we go. Notice that is x plus pi like that. And here, that's what that looks like. And it shifts it over. Everything moves over. Technically, you could probably say it moved right pi too, because it moves the same distance. Whoops, I did not mean to show you guys that. Let me go back to here. Okay. It doesn't change the midline or anything. It just shifts it left and right. Okay, and then this right here, when we multiply inside right there, it is going back to number 5 up here. It is actually a horizontal compression. That's actually our B value right there. And so that actually, if you think about it with your period, that kind of either squeezes in or stretches it out horizontally. So since 4 is greater than 1, it's going to be a horizontal All right, because it's greater than 1, it's going to be a compression. And the reason why compression is it's going to shrink in like this. It's going to compress in. All right. So horizontal compression of 4. All right. Now, again, it changes our period from being 2 pi to you would do 2 pi over b. Okay. So that makes pi over 2. So a full cycle's in a length from 0 to pi over 2. All right, number 2, multiple choice. Here's the graph of a trigonometric function. Which equation has this graph? Now, you can sit here and actually graph these, but let's kind of look at this for a second. Now, my midline right here is 0. Well, none of them have anything added out there. Okay, so now let's look at this. All right, the other thing is the amplitude. Okay, this is the amplitude right here. Okay, amplitude is 3. So I can knock out anything that is not 3 like that. Now, if you're clueless and you're like, I have no clue, you can graph both of these, and I'll do it in just a second. But here's a hint on this one. Here, our b value equals pi. All right. So here, if I do 2 pi over pi, okay, 2 pi over b, I get 2. This is my period, the length of one cycle. Well, notice here, the length of one cycle goes from 0 to 1. So my period is actually 1, not 2. So it's this right here. I think. Oops, I lied. I took these. Go back. What did I do wrong? Our amplitude is not 3 because I read this wrong. Our amplitude, look right here. This is 2 right here. This is 1. So really, what is that? Our amplitude is 1.5. So I'll back it up. Well, what represents 1.5 here? 3/2. So actually, I could mark off this. Now let's go back. All right, period. I'll start here. 2 pi over b. Our b value is 2 pi. Well, look, that equals 1. Now the distance here from 0 to 1. All right. And this is it. But again, we could sit here and graph it. All right. So let me plug in the 2. So -3/2 sine of 2 pi x. All right. So there's that. But what you might want to do is actually theirs goes from an x value of -1 to an x value of 1. All right. And then the y-axis goes from, we'll just say -2 to 2, just so you can see what they're looking at. And if you notice, that is that graph. Now, if I plug in -3/2 sine, of x plus 1/4, you're going to see that is definitely not that graph. All right. Especially when you put in the window that they have. And I highly suggest changing your window. All right, now let's go to Jada, Noah, and Elena. They are riding a carousel. Here's a view from above of the carousel. The carousel moves in a counterclockwise direction. So it's going to go like from J to N to E, the opposite of a clock. All right. When the ride begins, Jada is at position J, Noah is at position N, and Elena is at position E. The measure of the angle JON, all right, is pi over 2. The measure of angle NOE is 2 pi over 3. Okay, so just know that. The radius of the carousel is 20 feet. All right, how far does Jada travel to reach Noah's starting position? So Jada travels from here to here. I'll put it in orange. Okay, now how far does she travel? This is going to be arc length. And if you remember arc length, so Jada, she travels to Noah. All right, arc length is radius times radians. All right, so here the radius is 20, the radians is pi over 2. So here 2 divided by 20 is 10 pi. All right, so that's the answer to the first question. All right, so this time, what about Elena's starting position? So this time, let's put We're starting at Jada and we're going to Elena right here. Okay, now here we're going to add both of these together. So that's going to be our radians. Our radius is still 20, but I've got to do 2 pi over 3 plus pi over 2. Okay, well, think about that. That's like when you're taking your calculator, all right, and think about adding 2/3, all right, plus 1/2. I'm just not putting the pi's in. All right, so that makes 7/6. So really right here, this is 20 times 7/6 pi. All right, if I multiply the tops, that gives me 140 over 6 pi. And then here I can take a 2 out. So that's going to make a 70 and then 3. All right, like that. So the distance from Jada to Noah is 10 pi. Here, the distance from Jada to Elena is 70 pi over 3. All right, and again, you're finding arc length here. Okay, we got some more problems on another page. So let's look at number 2 right here. Angle theta measured in radians satisfies the cosine of theta equals 0. What could the value of theta be? Select all that apply. All right, now think about it. Where does cosine of theta equal 0? Well, what do you remember cosine is? Cosine is y. Where on the unit circle is y 0? Right here and right here. Okay, and if you remember those radian measures, that's pi over 2, and this is 3 pi over 2. All right, and I lied. That is not y, that is x. Where is x 0? X is 0 on these two axes. If you didn't remember what those radians measures were, go back to here. Let me delete that off. Okay, and remember your circle right here. Okay, it's in radians, and right here, that's pi over 2, and down here, that's 3 pi over 2. I just know it up here, and the more you use it, then you'll remember. Okay, so it could be 3 pi over 2. It could be pi over 2. Now, let's go eliminate the rest of them. 0 is right here. Well, here at 0, x value is 1, so it's not that. Pi over 4 is here. And if you remember, that's the 45 degree. Okay, that's square root of 2 over 2, square root of 2 over 2. So the x value is not 0 there either. And at pi is on the other side of here. That's the point -1, 0. And the x value is -1. So it's not 0. All right, moving on. Number 3. Here are the graphs of two functions. Which is the graph of y equals cosine of theta? All right, think about when we first drew this out. Okay, graph 1, I'm going to highlight in orange just so you can see it better. And then graph 2, I'm going to highlight in blue or trace it in blue. All right. So here, when we talk about cosine, and you can sit here and graph it and put it in the window if you would like. Otherwise, really just know something about it. Cosine starts above the midline. The midline on both of these is 0. Okay, so here, this one has to be graph 1. Now, which is sine of theta? Well, this has to be graph 2. Okay, because sine of theta starts on the midline, and that's our orange graph right there. And again, you could plug both of these in. All right, I have to go back to here. And I could say cosine, I'm just going to put x and then sine of x. But again, you want to go from the x values of 0 to 2 pi. So 0, 2 pi. And then here, -1 to 1. All right. And you can see that, okay, cosine is the red. So that's graph. I lied again. I got these mixed up. Sorry. All right. So this one's graph 2 and this one's graph 1. All right. So cosine starts here above the midline. It's the blue one. All right. And then sine starts at the midline, and that is the orange one. Yeah. Sorry, I messed up. All right. Number 5. A rotation takes P to Q. So I'm going in this direction right here. So P to Q. What could be the measure of the angle of rotation in radians? All right, so it takes P to Q. So if I go this direction, that's just pi over 2. All right, but they actually didn't say clockwise or counterclockwise. I just assumed you could actually go this direction. Now realize that's actually going to be negative. All right. So that could be a negative. It could also be negative, and that's pi over 2 plus pi over 2 plus pi over 2 would be negative 3 pi over 2. But I don't see that answer right there. Okay. Now we can go see if we can eliminate some of these. Like 3 pi over 2 would land us right here on this axis. So it's not that. Pi over 4 is right here in the middle in the first quadrant. So that's not quite enough. 5 pi over 2. Now these are already broken down into 1, 2, 1, 2. So if I go 1, 2, 3, 4, 5, do you see how that lands right at Q? It's just I went around and then some. And then 5 pi over 4. Okay, that's when you divide this up into fourths. So 1, 2, 3, 4, 5. That lands us in the third quadrant. So that's not Q either. This is knowing about radian measures, right? And how you're going around a circle. All right. Number 9. Here's a graph of sine of theta. Plot the points on the graph where sine equals negative 1/2. Well, where does sine equal negative 1/2? Well, think of your unit circle. All right. Well, think. It's the y value. Negative 1/2 lies right here. So right here, this is where y equals negative 1/2 because that's the y value right there. All right. Y equals negative 1/2. Okay. Well, what do you know where it is? Okay. And that's the second question. For which angles of theta does sine equal negative 1/2? Well, think back to your unit circle. Now, notice this. Do you see how it's kind of in between pi and 5 pi over 4? Okay, 5 pi over 4, and I'm just going to use this thing right. 5 pi over 4 is right here. Okay, well here, what is that line that was right here? Okay, that's the one that's divided by 6. Okay, and think about when it's divided by 6. So I've got 6 here. Ignore the middle one. So 1, 2, 3, 4, 5, 6, 7. That's 7 pi over 6. All right. And then here, this other one lies in between 7 pi over 4 and 2 pi. So sine negative 1/2 would be down here. So it's actually going to be over here. So if this is 7 pi over 6, this is 8 pi over 6, 9 pi over 6, 10 pi over 6. That's 11 pi over 6. That's when both of those times, 7 pi over 6 and 11 pi over 6, is when theta, sine of theta equals negative 1/2. And you can actually plug this in, all right, and double check your answer. If I do the sine of, put a parentheses, 7 pi over 6, all right, do you see how it equals negative 1/2? And then the same thing, the sine of 11 pi over 6. All right, negative 1/2 again. You can also do this, the sine of x. Where does it equal 1/2? So put y equals negative 1/2. All right. And here you only want to go from, on your x values, from 0 to 2 pi. All right. And here, negative 1 to 1. All right. And here you see that graph, and it shows you, didn't we do it? 7 pi over 6 and 11 pi over 6. So that's another way to do it as well if you have no clue how to do that, and know where it equals. All right, last one. We're going to write trig function for each one. All right. Now, to write a trig function, my suggestion is find the midline. Here, the midline appears to be at 30. Okay, so the midline is y equals 30. All right, now that means right here, the amplitude from 30 to 40 is 10. So A equals 10. And is it positive or negative? It's positive because it starts here and goes up. Now, is this sine or cosine? Sine, because it starts on the midline. So y equals positive 10 sine. All right, plus 30 is going to be out here. The hardest thing is to figure out that b value. But remember, we've talked about b equals 2 pi over the period. Okay, the period is the length of one cycle. So it goes from 0 to 2 pi. Okay, so 2 pi, so you're going to 2 pi over 2 pi. What is that? 1. So my B value is 1. And then I just put X. We're not going to talk about a phase shift plus or minus X anything. All right, now this one. Okay, we've got to find the midline. And the midline is right here at y equals -2. All right. Now, the amplitude goes from the midline to here. So if you notice, from -2 to -1 is a total distance of 1. All right. And I want you to notice this starts above the midline. So A is positive. All right. So let's get started. Y equals, if you want to put the 1 there, you can. Is this cosine or sine? Cosine, because it starts above the midline. I'll find my B in just a second. I'm just going to put a -2 for my midline. All right. Now, key is that right there. This goes from 0 to 2 pi. That means my period, again, is 2 pi. And remember, it's the 2 pi over the period, so 2 pi over 2 pi. So in this case, this one's also, my B value is also 1 here, so 1x. All right. Go back and review how we did some of these problems. These are all different problems that you could see with trigonometry coming up on your test soon. All right, we'll continue to review as well, and please ask your teacher any questions if you have them.